First is ipconfig. In the following procedure, we'll utilize the ipconfig utility and show the various parameters that are part of the command. To demonstrate this, I'm going to go to the command line and first run a basic ipconfig. You've seen this before. It's showing us the wireless network connection, the IP address, subnet mask, and default gateway. If you want to learn more about ipconfig, you can type ipconfig/question mark. That'll give you the usage or syntax for ipconfig, and it'll give you the options, otherwise known as switches or parameters, that can be used with the ipconfig utility. Let's show a couple of those now. First is ipconfig/all. I use this a lot in the field when troubleshooting network connectivity issues. It shows you a lot more information than just a standard ipconfig, like the host name, the wireless network you're connected to, the MAC address, and the DNS servers that you're connecting to and using. Also, it shows the DHCP is enabled, and that means I'm getting this IP address from a DHCP device. That brings us to a couple more switches that can be used with ipconfig, /release and /renew. If I wanted to remove the IP address that I'm getting from the DHCP device, I could type in ipconfig/release. And of course, all these pop-ups are going to come up because we've lost our IP address, we've removed it, and now the IP address is known as 0.0.0.0. Sometimes you have to do this when troubleshooting a connection on an IP network. Perhaps the DHCP device has been reconfigured, or there's a new DHCP server on the network. I don't know, maybe when you're troubleshooting a WAN connection, you have to release and renew the IP address so that the ISP can give you a new IP. This happens sometimes. If I want to get the address back, I type ipconfig renew, and that takes a few moments, and most likely we're going to get the same address back. And we do. 172.30.250.3 is the same address that we had before. The main reason is because my original lease hasn't ended. The original lease wasn't supposed to end until a couple days from now. So what's going on here is the operating system remembers the IP address. It keeps that information in the registry. And so really it just gets the same address back. A couple more commands that deal with DNS. The first is ipconfig/display DNS. This will show all the connections that you've made to various host names and websites. If you want to flush this information out, you could do that with an ipconfig flush DNS. That'll flush out the DNS resolver cache and anything that you might have connected to. Sometimes this is necessary to make a new connection to a newly configured DNS server. Now, after I've done this flush DNS, if I go back and do a display DNS again, it only gives us basic information. It really just tells us about the local host. If I wanted to connect to a new DNS server and be initiated with that DNS server, I would type in ipconfig/register DNS. And that'll start the registration with the DNS server. Ping! There's so much to talk about when it comes to ping. In this procedure, we'll demonstrate the usage of ping and the parameters. And once again, to demonstrate this, we're going to go to the command line. You've seen the ping command before, and first what I want to show is how to get to the help file. Now, you can do it with a /question mark, but you may want to get in the habit of using the --. Some TCP/IP utilities don't work with the /. You need to use the dash. So that gives us information here, the usage for ping, or the syntax, and also the options or parameters that we can use. The ones that I'm interested in for this particular lab are -T, -A, -N, and -L. We're going to use those 4 different options, and those are the most common ones you'll probably use in the field, and you might get questions on them on the Net Plus exam. Now, the ping command is great for troubleshooting, and when I'm troubleshooting a computer, I like to start internally. I like to start with the computer itself. And the best way to do this is a ping space localhost. This pings the local loopback address, which is 127.0.0.1. Every computer has this. And you don't need to have a connection to the network to do this test. As long as TCP/IP is installed properly, you should get replies, even if you're not connected to the network. And another example of this would be ping space loopback. And finally, ping space 127.0.0.1. Let's look at these three different pings that I did. The difference between the first two and the last one is name resolution. When you do a ping localhost or a ping loopback, it resolves the name to the local loopback address, the name of the computer that is, to the local loopback address. When you do a ping 127.0.0.1, you're kind of cutting out the middleman. You're cutting out name resolution and going right to the source. And that's a good idea in a lot of cases. When you're pinging a computer, ping by IP so there's no name resolution getting in the way. So I like to start internally with the computer and ping itself. Now you can also ping the logical IP address. In this case I'm 172.30.250.3. And I get replies. I could also ping my own computer name. Same IP address, but it resolves from name to IP. Now I'm positive that IP is working properly on my computer. Now I want to branch out to other systems on the network. So for example, I could do a ping space 172.30.250.4. That's another laptop on the network. Or I could connect to the router, .1. And then I can try connecting to computers on other networks. For example, I could connect to my web server, davidlprowse.com. And it resolves the name to the IP address that's being used by the web server out in the internet. So I like to branch out step by step with that ping command. Now let's talk about some of the switches for ping. The first one is the -t parameter. -t allows you to run a continuous ping to a specific IP address. Now you can put the -t before the IP address or after the IP address. I like to kind of keep the IP address after the command. So I type the command ping, then the IP address, and then the parameter. But it doesn't make a difference. You can put it wherever you want. When I do so, I get a continuous ping. It's going to keep pinging that other laptop on the network until I tell it to stop. And I could stop it by closing the command prompt or by pressing Control-C. Control-C will break out of that ping. This is a great command option when you're testing cabling. You can try connecting a patch cable to different ports until you find the live port that you want to be connected to. And once you get that live port, you'll get replies on the screen. So a couple possibilities for troubleshooting with -t. The next one is going to be ping-L. With -L, you can increase the buffer size of the packets that are being sent. By default, those packet sizes are 32 bytes of information. And we can increase that as far as we want, up to 65,500 bytes. So for example, I'll do a ping space 172.30 and we'll connect to the laptop again, .4 -L, and then I have to specify the size of the packet. I'll choose 1,000 bytes. When I press enter, you notice here that the packet size has changed from 32 to 1,000, and the time has actually increased a little bit, up to 7 milliseconds. Like I said, you can go as far as 65,500 within Microsoft operating systems. And those are going to be giganto packets. Notice the time it takes for those packets to get to their destination and reply back. That's like dial-up speeds right there. And you can really take down a network with packets this size. Now, this is the beginnings of a ping of death or a denial of service. Most routers will block this. They won't allow any packet sizes bigger than 1,500 bytes. So you wouldn't have to worry about it too much. And you won't be able to go beyond this in Microsoft unless you hack the registry. But again, most devices worth their salt won't allow anything larger than 1500 bytes. So there's your -L parameter. The next one is the -N parameter, which is the count. It's the amount of packets that you're sending in one particular ping. So I could specify that I want to send 10 packets altogether, and we should get 10 replies. So -N is the count. And what I like to do is I like to run tests on servers. As part of my performance analysis of a server, I'll run a test against the server with ping. And what I'll do is say run a ping to the device, and I'll run it with, say, maybe 100 count of packets. I'll just do 10 for now so it goes faster. And I'll do that with a specific size packet. We'll say 1400 bytes. And what I like to do is I like to save this information and do it every day or every couple days and compare that information and see if there's any variances. See if anything's different between the performance data. You'll see down here we get an average. If I see that this test tomorrow runs up at, say, 15 or 20 milliseconds, well, I may want to check why. I may want to kind of delve in a little bit farther and see what the problem is. Why is there more congestion on the network at one time than at another? Now again, I might do this with more packets, maybe 1,000 packets, and maybe even a larger size to simulate more data traffic or more congestion on the network. And also I could do this with a batch file and store the results in a text file for comparison to other tests later. And that's basically creating your baseline. The last one I want to show is -A. -A will resolve IP addresses to the host name. And I'm sorry, I forgot about this one. -A is one of those parameters that has to be directly after the ping command. So you run a ping -A and then the IP address that you want to connect to. So for example, pinging laptop-author. Don't go here. That's just a wireless access point name because I'm not part of a domain. So ping-A will take that IP address and resolve it to the name. And there you have it with ping. The parameters you really want to know are going to be -T, -L, -N, and -A. Tracert. Next we'll demonstrate the usage of the Tracert utility and one of its options, as well as a Tracert utility on the web. So again, we're going to go to the command line. The Tracert command is short for trace route. And what it does is it traces the route that packets would take from your computer to a final destination. That final destination could be on the LAN, or most likely it'll be on another network somewhere. Every time this trace goes through a router, it's considered a hop. The amount of routers in between you and the final destination is the amount of hops. Now the first thing I'm going to do is I'm going to tracer to a computer on this network. And very quickly, we get one hop. It takes one hop from me to that computer. And it does it in a triple ping, which shows us 3 milliseconds, 3 milliseconds, and 59 milliseconds to that final destination and tells us the trace is complete. To take this to the next level, we'll run a tracer to a website. For example, davidlprouse.com. Again, it's going to do 3 pings to each hop along the way. Here's the first hop, and you can find out some information here about the network that I'm part of, my ISP, even my location if you look carefully. So 3 pings to each hop along the way, each router along the way to the final destination, which is zosma.lunarpages.com. That's the web server that my website is being hosted on, and finally that IP address. Now this takes a little time because it's resolving this information to IP, it's doing a triple ping, and it's storing all that information in a table here for us to view. And now the trace is complete. To make that trace a little bit faster, You could do the tracert, but with the -D parameter, which is numeric. So no name resolution going on here. It shows IP addresses only. But it should show the same IP addresses that we showed in the first tracert. This command works well when testing to find out when a network router is down. If a specific router was down, you'd get stars. You'd get 3 stars or asterisks here, and it wouldn't tell you what router it is. But if you look at your network documentation, you could find out from that info which router is the one that's failing. And either the router may need to be restarted, or it may need to be reconfigured, or perhaps just turned on. Another way to do a tracert is on the web. I'm at speedguide.net, and you can use their tracert program at their website. What this does is it traces in reverse. It traces from their website out to your computer and your final destination. But it gives the trace route results pretty much the same: host name of the router, IP address, and the 3 pings. Okay, moving right along, and next we'll demonstrate the usage of the netstat utility and some of its options. So back to the command line, and if we just type netstat, we're going to get the basic active connections. I have a connection here to the local host right now, which is closed. So netstat by itself may not give you all the information you want. If you type netstat-a, you'll get more of the active connections that are running on this system. And we've shown this before. We've shown connections to the router, wireless access point, and to other websites and to network storage. This information may take time to come up on your screen though, and to make it a little quicker, we can change all the host names to numeric, to IP addresses. We would do that with the netstat-an, which by the way is not in the help file. That changes everything to numeric. IP addresses and ports are shown numerically. Netstat-e gives you the Ethernet statistics and the packets that have been received and sent by your network adapter. And to build on that, netstat-s statistics for your card, including IP version 4 statistics, ICMP version 4 statistics, TCP statistics, and UDP statistics. So you can get a little bit more information there. And finally, netstat-r gives us the routing table. And this routing table is something that is shown on any computer, but we're not really using it right now. We're not really routing anything. And we're going to show more about this routing in the upcoming lab. Now again, like I said, if you were to do a netmark, it'll show the help file and the various parameters you can use, but there's no AN on the list here. However, I'm sure you're going to want to use that in the future. Next, we'll demonstrate the usage of the NBTstat utility and its parameters. Back to the command line we go. Here's the NBTstat command. Just by typing the NBTstat command, you can get the help file when you press enter, and it'll show you all the parameters. Now, NBTstat stands for NetBIOS over TCP/IP statistics, and where netstat was used to test the local computer and analyze the local computer, NBTstat can be used on a local or remote computers. The NBTstat command will show NetBIOS information, and it'll also work even if you're part of a DNS network for the most part, because most DNS networks are backward compliant with NetBIOS. So let's show a couple of parameters for this. First, NBTstat-a will allow you to see the name table for a given machine, and when you use a -a, you can use the host name, or the NetBIOS name I should say, of the computer. So in this case, we'll do the local computer first, laptop-author, and it shows the NetBIOS machine name table. And what it's showing here are that specific services are running. For example, 00 is the workstation service. Very important service to have on a computer when you want to connect to other computers on the network. 20 is the server service. If my computer wanted to serve information, I would need to have the server service running. Those are the two big services of networking, and we see they're both running here. We can also do this to remote computers. For example, laptop-music. And that guy's also got the 00 and the 20 services running. So I can find out information about the services running on a remote computer. We can also do this by IP address with the capital A parameter. So for example, if I wanted to connect to that laptop-music, I would do that with the IP address and the capital A. And it shows me the same information. So if you can't connect to a system by name, and maybe there's an issue with the NetBIOS name on that particular computer, you can always try connecting by IP address. The way I like to remember it here is when you type characters, by default they're in lowercase. So a host name or a NetBIOS name, when you type it, would be in lowercase by default. And here's the lowercase -a. When you type numbers, they're always uppercase. There is no lowercase numbers. So uppercase A for IP address. A couple other parameters here. We have the -r parameter, lowercase, which gives you the NetBIOS names, resolution, and registration statistics, and how many NetBIOS names were resolved by broadcast or registered by broadcast. We also have -R, which will purge and reload the remote cache name table. And then we have R, which registers the computer in a WINS network. So a little bit about NBT stat. Next we'll demonstrate the usage of the NSLOOKUP utility, or name server lookup. And if we type NSLOOKUP in the command line, it'll bring us into a shell where we can do additional work. If we type the question mark, we can actually work with our DNS server and make changes to the DNS server with these commands. Whatever that name server may be, whether it's on the LAN or if it's on the ISP. This particular DNS server is on the ISP, so I'm not going to be able to make any changes to them. But what most people use NSLOOKUP for initially is to resolve host names or web names to IP address. So for example, I could type in the name davidlprowse.com and get a answer here, the address 216.97.236.245. Now if you're obtaining an IP address from a DHCP device, like one of those 4-port Soho routers, this may be blocked because it may add in a little DNS address of itself initially in your DNS information. So, and that's the case with my Belkin router. So what I've done is I've set up this machine to connect statically to the internet with a static IP address. I could type in other domain names like Microsoft.com, and it'll give the address or addresses that that name resolves to. Some have more than one, some have 4 or 8 addresses. When you're done working with the command and you're done being in the shell, you can type exit to get back to the original // In this last procedure, we'll demonstrate the usage of the FTP utility. And to demonstrate this, we'll go to the command line for the last time in this lab, and we'll type FTP. The FTP command allows us to connect to FTP servers by name or by IP address. I want to connect to the FTP server on my LAN, so I'm going to type its IP address now, and it's going to ask for a username and password, and if you typed everything correctly, it should say that that user is now logged in. For me, it's David P. And you'll know we're in the FTP utility because the prompt has changed and it now says FTP. Let's start with a pretty universal command, the dir command. When I press enter, it gives me a listing of the files on the FTP server. And what I want to do is I want to grab some files from the FTP server. Now, what a novel idea. I want to do file transfer. So let's do that. Here's test.txt. I so want that file. To get it, I use the get command. And we'll type get space test.txt. When I press enter, it's going to grab that file and download it to my computer. And it does it really fast. It opened an ASCII mode data connection for test.txt and completed the transfer. It was only 3 bytes. I mean, how long could that possibly take? 1 nanosecond? Who knows? But what we did here was we opened an ASCII mode data connection, and by default that's the mode that's going to be used. And that's what you want for text files and for most types of documents. Now you may ask, where did that go? By default, it'll go to the last known good directory that you were in prior to the FTP connection. And for me, that was the root of C. So test.txt should now be located in my root directory. If I go to Windows Explorer and go to the C drive, we'll see test.txt here. So it did indeed download it. That C:\/ is known as my local current directory. Okay, so now what I want to do is I want to give you a little information on the help system. If you type ? and press enter, it'll give you a list of commands that you can use. If you want to learn more about one of those commands, you type ? and the command you want to learn more about. For example, mget. And it tells us mget gets multiple files in one shot from the FTP server. Well, it doesn't say all that, but I'm inferring that. So we want to get multiple files? Sure. I want to get all these files that are on the FTP server. I want it all. So I'll use the mget command and type *, wildcard, meaning all the files. When I press enter, it's going to ask about each file individually. Do I want AC3 filter? I'll say Y for yes and enter. It'll download it. Then it'll ask about test.txt. Well, I don't really need that. I've already downloaded it, so I'll say N for no. And then it asks about USB 100M. I'll say yes and enter, and it downloads that. So we've done the get and the mget. Now what I'd like to do is I'd like to put files onto the FTP server. Now first of all, you want to say, okay, well, where are the files going to come from? And that's going to be your local directory. Right now the local directory is C:\\. But that's not where I have the file that I want to upload. The file that I want to upload is in a folder called ftp_uploads. So I'm going to change my local directory by typing lcd C:\ftp_uploads. Press enter, and it tells us that the local directory is now C:\ftp uploads. The file I want to upload is called setup.exe. And to upload files to the FTP server, we use the put command. So put space setup.exe, press enter. It opens an ASCII mode data connection, and it uploaded the file. To test that, I'll type dir and view the FTP contents, and here's setup.exe. Finally, we were talking about the mode, how you're going to send information. Well, you have 2 options. You have the ASCII option and the binary option. To find out what option you're using, type the type command, and that'll tell you right now it's using ASCII mode to transfer files. That's the default, by the way, when you first connect to an FTP server. But you can change that if you wanted to, and I do. I want to change it to binary mode. You see, I want to upload a graphics file, and when you move graphic files, ASCII mode will change the code. We don't want that. We want it to be sent in binary. To change it to binary mode, we just type in binary, and the type will be set to binary. If we type the command type again, it tells us using binary mode. Now the file I want to upload is in my FTP uploads folder. It's called lab15_routing.jpg. So I'm going to upload that guy now by using the put command, lab15_routing.jpg. It opens a binary mode data connection, and it uploaded the file. That's exactly what we wanted. So we use the dir command, the get and mget commands, the put command, and we changed the mode of transfer. And we also changed the local directory with LCD. Now, you may not want to use the command line when moving data, but it can be fast once you get used to it. There are other FTP programs like Smart FTP or FileZilla. So if you want to use one of those, you can. They work in a GUI mode, and it's easy to drag and drop files. That's about it for FTP.